Hello everyone, welcome to our webinar, Semgrep and Static Code Analysis for Projects on JuliaHub. In this session, we'll explore how JuliaHub supports secure and compliant Julia development through integrated static code analysis with Semgrep. Designed for developers in regulated industries like pharma, life sciences, and finance, this walkthrough will show how to automate code scanning, enforce coding standards, and keep your projects audit ready. So let's get started. And today our speaker is Venkatesh Dayanand. He's a sales engineer at JuliaHub. With this, I'll hand it over to Venkatesh.
Uh, Thanks, Sanjeev, for that introduction, and welcome everyone for joining this webinar. So today we will be going through how we perform static code analysis for project on JuliaHub. Um, I am assuming that our viewers will be familiar with what Julia programming language is. But few of few of you might not be familiar with the JuliaHub platform. So I think at first beginning, a couple of minutes, I'd like to go through what JuliaHub platform is and specifically some of the features uh, which are relevant to the context of static code analysis. The later part, we will discuss about the tool that we use for static analysis called Semgrep. And at the end, we will have a short demo on how we perform this analysis. Um, JuliaHub platform is essentially it provides an environment for Julia developers to develop, run, um, and scale their applications, and also to deploy their applications, um, uh, both in a cloud environment as well as systems which don't have access to internet. Specifically, we provide uh, features like features to host Julia libraries, packages, and registries. We provide uh, a way to create Julia applications leveraging these libraries, enabling to host it to be available for users who are just the consumers of these applications. We provide a feature called projects, which sort of manages or brings together both code and data relevant to the Julia application. Uh, and given that in an enterprise system, there will be multiple users who will be collaborating on this Julia applications, we provide necessary uh, features to do collaborative editing, sharing of resources, as well as to provide access control mechanisms uh, as well. Projects in JuliaHub are typically managed by some of the applications which come integrated with JuliaHub instance, like JuliaHub ID, Pluto servers, and many others. Um, these integrated applications uh, uh, are most of which are developed by JuliaHub, but we have also some of the third-party applications available for our customers. Um, let's go in a little more detail into some of these features, um, specifically which deals with the source code on which we will run the analysis um, shortly. So the first feature is the package server, where essentially we provide a way to browse through packages similar to what you find in other language ecosystems like NPM. Um, uh, so users will be able to, view their documentation of their packages look up the dependencies and reverse dependencies of the packages, and all the surrounding metadata associated with the repository is visible and is along with that, we have added a new, we have newly added a section called static analysis, which gives a report of uh, the static analysis, which has run across versions of those packages. And of course, packages are ultimately utilized by Julia processes. So our Julia Hub serves and sort of supports the package server protocol utilized by Julia itself to download libraries. So in this screenshot, as you can see that uh, by just setting an environment variable to juliahub.com, users can add the registries which are proprietary to juliahub.com and also use the proprietary packages. And of course, in instances where we deploy JuliaHub in the customer environment, the customers can also set up their own registries and download them and utilize them. So here we are looking at a screenshot of the project's feature, where if you see, this is a project called Secret Analysis, and the relevant key components of the projects are basically a section where we display the source code associated with the project. We provide a file browser. We also provide a section for datasets, which is used by the code. And now we have newly added a section for static analysis, which again, similar to the packages page, provides the report on the scans that were run on this project. A project, as I said earlier, is typically uh, has a application associated with it. So in this case, it's Julia ID is the default application, which when user clicks the launch button, starts a VS Code instance on browser. But of course, this project can be run with multiple applications simultaneously, and all the changes that were made by these applications are synced instantaneously. So here is some of the list of applications that come with the Julia Hub instance. Some of the logos will be very familiar to people. Some of them, these are third-party applications, and all of them operate on the project projects, and basically forms a foundation for the application. So we have now looked at the relevant sections in Julia Hub platform where we host source code. Now let's go into what how we run static analysis on these parts. So before let's start it by sort of understanding what static analysis is. So static analysis is essentially a process of examining the code without actually running it, in order to identify potential issues and defect. The goal being that to proactively improve the code quality, security, and reliability by detecting these problems much early in the development cycle, and also enforcing certain coding standards and best practices found. Um, because it is run because analysis happens without running the program, it saves a lot of time and resources for the users that otherwise would require extensive runtime testing. On Julia Hub, we use a tool called Semgrep to perform static analysis. It's an open source analyzer that supports multiple programming languages, including Julia. Um, uh, Most importantly, it allows us to custom write and reuse rules to find specific patterns and anti-patterns in the code by operating at a syntactic level, which which helps it to get much better insight than doing just a textual analysis. Um, uh, Semgrep. Now let's look into how we utilize Semgrep in JuliaHub. Semgrep primarily runs in two ways in JuliaHub. One is it can be triggered on demand on any of the project source code. This means developers can initiate scans on their project's code at any point during the development. The second way that we run is across all the packages and registries that are served on JuliaHub across versions. So ensuring that ongoing code quality and security for those packages. The analysis itself covers variety of categories ranging from security vulnerabilities, code correctness, best practices, and even code formatting. And In order to help our developers prioritize how to address these issues, Semgrep provides three different levels. Error, which pertains to serious issues, warning, which are not so serious issues, and the third category is note, which typically are minor problems or in most cases suggestions to improve the code quality. Uh, so on JuliaHub, we currently host around 60 plus public and proprietary rules, which includes 23 CWE rules, which I will explain in a little bit in a while. We also allow our customers to write their own custom rule sets, extending the existing rule set tailored to their specific needs and coding practices. The rules cover broad spectrum of areas in ranging from AWS, HTTP web sockets, JWT tokens, SQL, and of course the Julia language itself. If you are curious to see how the rule set looks like, I have provided a link to the public version of the rule set that we have on our organization. I would encourage users to view them. But of course, I'll provide a gist of what a rule set looks like and with an example later. So before starting with one of the important issues that we encounter in this uh, uh, static analysis scan may be related to security. So in order to talk about these security rules, there are two important key concepts that we need to understand. One is CWE, which stands for Common Weakness Enumeration. It's like a community developed list of software and hardware weaknesses. And if these weaknesses are not addressed, uh, this could lead to some actual real world vulnerabilities, which potentially could compromise the integrity, availability, and confidentiality of the software. And the CW which stands for Common Vulnerability Exposures, is a method of identifying such vulnerabilities. Uh, and it's actually maintained by an organization called mitray.org. So in our scans, we will try to identify areas in our code where such CWEs are present. So as I said earlier, we have covered around 23 CWE rules in our current rule sets, and it's growing. Let's go into one example of what a CWE is. So here is a CWE, which is CWE 47, which pertains to null pointer dereferencing. Null pointer dereferencing happens when the code tries to uh, access a invalid memory location or a null memory location. Um, so let's see how a Semgrep rule would look like in order to catch this error. So here is a part of the Semgrep rule. Um, I think the important point is this is split into three parts, which is if you see this called pattern sources, where we specify how to catch, uh, identify the sources where uh, uh, basically input sources where this vulnerable CW could originate from. And there is something called pattern sanitizers. It identifies pattern within the code which cleanses or maybe sanitizes the sort of the tainted area by making it safe. So in and the third part is the pattern sync, where identifies the section of the code where the the source must not flow into. Um, I'll come up with an actual code example to further, make it much more clear what I meant. Um, the other part of the rule set mainly has the metadata associated with the rule set, which is used in the reporting. So here, if you can see, there is a message, exact message that needs to be displayed in for the user to fix the issue. It has other metadata like the severity and the level, and when applicable, uh, CWEs that are associated with this pattern. So in this case, it is CW 76. So here is a code example where this CWE, we would encountered issue related to this CWE. So if you see that line number one is the null pointer address that we are setting in the variable P. And clearly in line number four is where the issue is, right? Because we are now trying to do an unsafe load on this null exactly. So at this point, we would report an issue, line number four. We also do an unsafe load in line number eight, but as you can see that it is wrapped around with a null check. So we will never hit that point. So our analyzer will not report this particular line as a one with issue. And also similarly, line number 14 is also an unsafe load, but in this case, our analyzer is able to detect that it is not a null pointer, it's actually a valid memory address, line number 11. But however, in sections like which start with line number 16 and 21, again, we are trying to uh, unsafely load or store the pointers. So all these will be caught in our analysis. Let's see some. So here's a short list of actual vulnerabilities which are associated with this CWE, null pointer dereference CWE. You would find more examples and detailed explanation in the official website of mitre.org. Yeah, which is it's well articulated, and it's very interesting to go through many of this. Now, at this point, I would like to give a short demo of how this works in JuliaHub. Before we go to that, let me quickly check if there are any questions. Okay, there are no questions. So let me please. So, so this is a JuliaHub instance. So let's now try to uh, give analyze a toy example code to see how uh, analysis, how a user would use the uh, static analysis feature in JuliaHub. So let's create a sample project. Um, Um, so, so this is the project page that we saw earlier in the screenshot. Right now, there are no files in this project because by default it will be empty. Let me, I could upload a file from this interface, but let me try accessing this project using the Julia ID. So since the default app here is Julia ID, if I click launch, I think it should uh, open this application. Let's give it a few seconds for it to load. Okay, now we have a VS Code instance which has loaded the project. Let me try to create a example file. So I've pasted a code snippet. This code doesn't do anything useful. It's just to demonstrate the various issues that we could potentially uh, run into. Um, Let me, without further analyzing or giving an overview of what this does, let me try running an analysis on this to see what it catches. So see, try to refresh. So as you can see that, uh, as I said earlier, uh, the modifications made to projects are instantly synced across applications. So you can see the file that we created here as well. But let's try running a scan on this file. So I've initiated a scan. It should take a couple of seconds. So the scan has finished, and you can see that we have got few warnings. Uh, I'll give an overview with a real with a more I'll later show an example with a package which will have much more issues, so I can show the CWVs, etc. But for now, let's try to fix the issues that we have currently captured in this code. So the first issue that we see is that the global variables should all have uppercase name with underscores. So this is one of the rules that we have. So we can preview the exact line which is actually affected by this rule. So right now it is line number 4. So I can make modifications here. Oops, I changed it. I have to change here as well. The other change, the issue that we see is no implicit return statement. Okay, so it's always good to explicitly have a return statement inside a function definition. So let me add it here. In this case, we are returning this expression. Try. What else do we have? Okay, there are few blank lines. I think I've already removed them. Further remove. And the last one is macro chain after function call. So yeah, so we clearly see that macro lookup, dynamic macro lookup is considered an anti-pattern. So let's try, not doing that. So let's comment this code. Let's now hopefully it should resolve all these issues. Let's try scanning again. Yeah, all good. I think we have fixed all the issues. So this is what we expect the developers of the projects to run the scan as frequently as possible to ensure that the the code quality is met. Um, so we not only scan package projects, but also, as I said, packages also scanned. So let's look at an example of a registry which is configured for code scanning. So here we have a registry called demo registry. Let's see. So we now have a scan report across all the packages in this registry. So there are, let me show the category that we discussed earlier about security category. So now we see that there are a couple of issues in one of the packages, not couple, but I think a lot of issues in this package called losing model. And this is related to CW333, which is use of cryptographically weak random number generator. By clicking this icon, we can directly go to the CW page where we'll have more detailed information about this. The suggestion provided in the rule set is to use random device instead of rand or random. Similarly, uh, we have I think a lot more issues in CWs detected. But the idea is that um, this comes to notice well before we, sometimes make it available for the users of these packages. Um, so we can browse these issues per package. I think. Um, and for some reason, the package doesn't show up in the dropdown. Might be a bug. But here we also provide a graph of this count number of issues that were encountered over a period of time across in this particular registry. And for some reason it's not working, but when we select if we select a particular package, we would have the same graph, but now across all the versions of that package. So over the time, we will see we should note is in reduction of these severity counts if they are addressed properly. Um, and of course, uh, okay, I think now it's working. But in this case, you see that it seems to be increasing with version because I think more code is getting added, but the issues are not addressed. Uh, we can see the exact count across versions uh, by selecting, and users can zoom and set the scale as necessary. So yeah, so the feature is still in its early stages, and I think we have rolled out this feature in 6.9, which we recently released last week. We want to do much more here. Uh, so some of the future work that we have is currently we scan only the code of the project, but not we don't detect or report issues which are present in the dependencies of the project. Uh, in future, we want to show that to users as well. And the much more exciting part would be to have additional tools like Jet or Aqua, which provide much in-depth analysis of like in particular Jet provides catches issue related to type stability and performance, I think, which are very vital to our developers. Um, by integrating these tools, I think we will provide more in-depth analysis and insights. The last point that we want to do is to uh, enable our customers to direct manage these rules or edit these rules directly on our platform. Right now, these rules are hosted in a Git server, and we have to configure the Git repository in JuliaHub in order to sync those rules. But I think it would be much better if our users are able to, filter certain rules or easily add certain rule sets according to their, you know, policies or coding practices or whatever. That's all I have in this webinar. Uh, I thank you, and uh, I'm so open for some questions if there are any.
Yeah, if you have any questions, you can type it in the Q&A section and we'll answer them in the order that's received. Yeah, see, there are no questions right now. So what we'll do is this webinar has been recorded, and the recording will be posted on our website in a couple of days' time. You would also receive it via an email that we will send out. And in case you have any questions, you can always reach out to us, and we'll get back to you at the earliest. And I would like to thank Venkatesh for this insightful session, and we would like to see you in our future webinars as well. Thank you, Venkatesh. Thank you, everyone.
Thank you, everyone.
Have a good day. See you.
Bye.